Welcome to our channel. In this session, we are going to discuss an example of knapsack problem using greedy approach. So first of all, what is a knapsack problem? They are given some profits and weights of some objects and a knapsack with some capacity. Your aim is to place the objects into the knapsack such that you need to maximize the profit. So this is a maximization problem. Remember, this concept is implemented by using either greedy approach or dynamic programming or backtracking or branch and bound. Means here the concept is knapsack problem. This same problem is implemented by using different algorithm design technique. Now in this session we will discuss how to implement the knapsack by using greedy method. Now simply the procedure is, here consider this example. They are given 7 objects. Each object have, these are the profits. W1 to W7 specifies the weights. The first step is calculate the ratios of profit by a weight. Why? Based on this weight, suppose if the ratio is high, you are calculating profit by weight. If the value is high means more profit, less weight means we need to place that objects into the knapsack. So calculate P1 by W1. What is P1? 10. What is W1? 2. 10 by 2, that is 5. P2 by W2. 5 by 3, that is 1.66. P3 by W3, 15 by 5, that is 3. P4 by W4, 7 by 7, value is 1. Next, P5 by W5, 6 by 1, value is equal to 6. P6 by W6, that is 18 by 4. So approximately 4 the 6, 24.5. P7 by W7, 3 by 1, 3. Okay. The first step we completed. What we have done? Simply calculate the ratios of profit by weight. Now, in which order we need to place the items into the knapsack? According to the ratio value in descending order. Again I am repeating. If the value is high means more profit, less weight. Why? In the numerator you have profit, denominator weight. If the value high means the profit is high, less weight is less. Now according to this situation, first which object you are considering? Observe, among all these, this is the highest value. So first you need to place this object. Okay. Next, what is after 6? The next value is this one. This is the second one. And after 5, this is the third. And here P3 and P7 both have values 3. Which one you need to consider? Here there is no restriction. You can consider anything, but better if the same ratio occurs in that situation, first to consider high profit one. Even though you are considered this one, that's not a problem. Now this is my fourth one, this is my fifth, finally this is my sixth, and then this is 7. Here what is 1 to 6? The order. In which order we are going to place the items. Clear? Clear? Now place item by item. First I am considering the fifth object. By considering the fifth object, what is the weight of the fifth object? 1. Initially, what is the capacity? 15. By placing the fifth item, 15 minus 1, the remaining capacity is 14. You got my point? Once you are placing one item into the knapsack, means simply a bag. Once you are placing an item into the bag, simply reduces. Now, for my understanding, I used one instance x5. What is the value? 1. The meaning is the fifth object is completely placed into the knapsack. If it is completely placed, I given a value 1. After fifth object, next to consider the first object. What is the capacity? Previous capacity 14. Now subtract the weight of first object 12. That is, my first object is also placed successfully. The value is 1 I given. After 2, here sixth object. So M is equal to the remaining capacity 12 minus 4, 8. So my sixth object is also placed successfully. Clear? Now after 3, third object. So M is equal to 8 minus, what is the weight of third object? 5. 8 minus 5, 3. So x3 is equal to 1. So my third object is also placed successfully. Next to fifth one. M is equal to remaining capacity 3 minus weight of seventh object. What is the weight of seventh object? 1. The remaining capacity is 2. My x2 is also, x7. x7 is also placed successfully. Clear? Now M is equal to, what is the sixth one? This one. My knapsack capacity is 2 only, but my object weight is 3. Is it possible to insert the complete object? No. Why? My capacity is 2, but I have 3 weights. So in this, what is the value of x2? 2 by 3. What is the meaning of this one? Only 2 portions are allocated. If you place it completely, the value is 1. If you place only a fraction, the capacity, knapsack capacity by weight of that object. Now anyone is remaining? x4 is remaining. What is the value of x4? Till now there is no space. Simply, even fractional part is also not possible to include. Like this, you are calculating each x1 to x7 values. Once the calculation is completed, now I am erasing this one. What you are doing? Sigma Pi into Xi. What is Pi? Profit. Xi means the corresponding instance. Now calculate carefully. P1 into X1 plus P2 into X2 plus P3 into X3. First to P1 into X1. X1 is completely placed. My P1 is 10. 10 into 1, 10. Plus P2 into X2. What is the P2? 5 into, what is x2? 2 by 3 plus P3, the complete object is placed. P3, the complete object is placed. P4, the object is not at all placed. P5, the complete object, that is the total profit. You got it? If the complete object is placed, you are getting the total profit. Now P6, where is P6? Here. P6, the complete object is placed. For P7 also the object is placed. Now calculate the total. 18 plus 6, 24. 24 plus 3, 27. 37, 37, 47, 47, 52. 52 plus 10 by 3, 3 point some 5. So 55 point 10 by 3, 3.3. 55.3. This is the maximum profit you are getting for this example. Now you understand? The procedure is very simple. Calculate the ratios of profit by age and place the object according to the descending order of the ratios. If an object is placed completely, then that instance is 1. If it is not placed completely, value is 0. If only some fraction is placed, the profit is only for that fraction. That is the reason for that profit. If you are placing complete item, you are getting 5. Suppose if you are placing only 2 parts, you are getting only that profit. Only that profit. Now this is the total profit you are getting for this example. This is the greedy knapsack. Thank you.